Good evening, everyone. I'm Helen King, Principal of St Anne's College and Co-Chair of the Steering Group of the Centre for Personalised Medicine. It's a real privilege and delight to welcome you here this evening and also to welcome those people who will subsequently view this lecture online. St Anne's is very proud to be home to the Centre for Personalised Medicine and to work with the Wellcome Trust Centre for Human Genomics to support the work of the centre. And I think we're all really excited to have a new director and to be holding this inaugural lecture for Professor Anneke Lucassen this evening. Anneke studied medicine at the University of Newcastle, and she did her higher medical training in Oxford before going on to do a PhD in molecular genetics of multifactorial disease. She specialised in clinical genetics and was appointed to a consultant post initially in Oxford in 1997 before moving to Northampton, where in 2007 she became Professor of Clinical Genetics. She established in Southampton a research group that explores the ethical, legal and social aspects that need to be addressed in order to integrate technological advances in genetics and now genomics into healthcare. We're delighted, and she appears to be delighted herself, to be the new director of the Centre of Personalised Medicine, which has as its aim engaging wide audiences about the effective delivery of personalised medicine. It seems a natural home for her and for her research. I hope she's also pleased to be back in Oxford, and she's now an honorary clinical consultant in the department where she initially trained. Personally, Anneke comes maybe from many places. She was born and grew up in the Netherlands initially, and then moved to the UK and went to school in Birkenhead, an area of the country that's quite dear to me too. She spent 7 years in Newcastle at medical school, which is a centre this college works very closely with schools to encourage students to consider applying to Oxford. So we have another link there. But she met Tim, her husband, in Oxford, and her daughters were born here. So after 20 very happy years in Southampton, we hope that they're beginning to feel like they've come home in some senses. So tonight we're going to hear about the promises of genomic medicine, an interdisciplinary approach to translation and implementation. And I'm sure you'll join with me now to welcome Anneke as we listen to her lecture. Thank you.
Well, thank you so much, Helen, for that introduction. And I am really excited to be here and a little bit nervous about doing a talk in person for the first time in 20 months. I've actually got the full smart outfit rather than just from here on up. And when the possibility of a job back in Oxford first came up, I couldn't actually believe my good fortune when I heard that Simon Leedham was stepping down as director of the Centre for Personalised Medicine and that a new director was being sought. So Simon, thank you so much for feathering the nest of the CPM director's post so well and reaching out to so many diverse areas in your role. I'm really excited to take this on. We now have 4 JRFs, quaint Oxford term for Junior Research Fellowship, which actually means that you've got to have independent funding and be really quite experienced. But the 4 JRFs really help the CPM to thrive, and the Oxford Society, the student society, is really flourishing too. And then as a whole, this interdisciplinary team, I'm just really thrilled to be involved in. So before I start, I just wanted to say a little bit about my take on personalised medicine. And in many ways, I think that medicine has always been personalised. It's always been targeted to the patient in front of you. And so in that sense, I'm with the people who, when this term was first coined, said, oh, personalised medicine is just the emperor's new clothes. But I think there's also a more positive way to interpret the term, and that's the one that I think is the more promising one, which is that as scientific developments and technology have exploded, such that our gathering of data about health has also exponentially increased, we need to really recognise that that data won't speak for itself. You can't just look at the data and say, this is what it means for medicine. You really need to take the context and the individual patient in front of you into account to be able to tailor that massive explosion in data appropriately. And that's my take on what we mean by personalised or precision medicine or stratified medicine. So what I hope to persuade you in this talk is that in order to personalise medicine with these advances, we need to bake the ethical, legal and social aspects into that pipeline. Otherwise, the promises from the scientific and technical advances will not be successfully translated into healthcare. And my own journey through personalised medicine began here in Oxford in the early 1990s when I did a DPhil in John Bell's lab, part of the Bell-Todd empire on susceptibility factors in type 1 diabetes at the time. And I made some very optimistic predictions about how my findings from my research would soon be translated into care. So in my thesis summary, I said the technological challenge of defining all the genes involved in common complex diseases is rapidly being met. Once these polygenic risk factors have been identified, screening tests could be rapidly transferred to the clinical setting. I did add, however, it is not clear what the impact of such information will be, and there are also potential problems. And I became very interested in that, however, and went to finish my clinical training just as testing for single gene disorders was becoming possible. And I trained in clinical genetics, became a member of the Oxford Clinical Genetics Service, at the time part of 23 regional genetic services around the country. Now there's been a lot of restructuring of these recently, so that we now have genomic laboratory hubs and genomic medicine service alliances and genomic medicine centres just before that. And I've forged a path through Oxford to Southampton, now back to Oxford again. In Southampton, I set up a research group to look at some of those ethical and legal issues that were arising in practice and try and see if we, by looking at them in more depth, we could translate them or make useful discoveries for healthcare translation. And I realised that my enthusiasm about my DPhil predictions had been a bit too enthusiastic, because I would say that some 27 years later, none of the findings that I made in my PhD have been translated into practice. So the group that I set up in Southampton is the Clinical Ethics and Law Group, and here is some of its current and recent membership. I'm thrilled to see at least one in the audience. The sales group aims, the mission statement of the sales group is that rapid technological advances promise big improvements in medical care. Sales provides the leadership in understanding and responding to the ethical, legal and societal aspects of these radical changes through empirical and conceptual research, education, policy engagement and public dialogue. I don't know if you can see that, the 5 outlined at the top are people who have already or are in the process of moving to Oxford with me. And I just wanted to acknowledge Angela Fennick at the bottom right there, who helped set up this group and with whom I got my first grant to research some of these issues, but sadly she retired last year. Another early collaboration with that was really important in setting up this research was with Mike Parker, who is director of the Wellcome Trust Centre for Ethics and Humanities here in Oxford. And on the back of some Wellcome Trust funding, he and I and some other people organised this professional group called the Genetics Forum, which was set up as a practical ethics support network so that people could bring cases that were arising in their clinical practice that raised ethical or legal issues for them and have a point for discussion. And although initially we thought we'd just have 1 or 2 meetings and then we'd have solved everything, some 60 meetings later there's more and more demand for it, and at our next meeting we've already got 250 people signed up to join us. We've presented that those meetings have resulted in more than 1,000 cases being discussed and analysed and translated into practical ethics support, but importantly have also been the basis for several position papers and professional guidelines. So I think it's been a great national ethics research lab. So what I thought I'd do in this talk is I'd pick 3 themes where I think these research approaches have resulted in a different slant or a change in thinking about practice, and show you how an interdisciplinary approach has really made a difference. I could pick others, but I think 3 is enough for now, and maybe I can come for a follow-up another time. So the 3 ones that I've picked are what do we do about disclosing genetic information that might be relevant to family members? When should we do it? Who should do it? Is it a can, a should, or a must situation? The second theme is what do we do about the deterministic discourses that exist around genetics and genomics, and how can we be prepared to deal with them in different settings? And then a third theme is about hybrid practices, so where research, clinical practice and commercial activity sort of become baked together in a way that current governance processes don't really help us with them. So the first theme has been a real recurring theme for the genetics meetings that I just mentioned since the early days, and still I would say 50% of all the cases have some element of what do we do about this familial information in this particular case. And I think just a sort of background bit of information here is that modern healthcare, I think mental healthcare probably always has, but modern healthcare in particular focuses on the individual patient. So when you discover potentially familial information, when is it appropriate to think about their family members and what their rights to know are? And I think baked into that is that the best care for individuals often is the result of comparing the patients in front of you data with existing data that's been collected about lots of other patients. Increasingly, we need large international collections of really good quality genetic data linked to clinical features to be able to know what a particular genetic finding means. And so the question then is, should individuals be able to benefit from genetic testing, but veto that the use of their data for other people? And Mike Parker and I first thought about this really early on and wondered whether genetic information, or at least the genetic information that potentially had familial implications, should be judged differently from a lot of other medical data. And we argued that that particular information was actually was at least potentially familiar and therefore joint information. We use the analogy of a joint account, but actually I think a joint family story is probably a better analogy. And so should we invert the traditional views about confidentiality, that the confidences of the patient in front of me are the most important, and that people who aren't in the room are sort of take a lower priority in that view? Can we reverse that view and assume that the information should be available to other people to whom it might be relevant, unless there are very good reasons not to do that? And we were really pleased when this thinking was incorporated into General Medical Council guidelines. So in 2009, for the first time, the GMC introduced a potential obligation to disclose specifically genetic information to certain relatives without the consent of the proband, the person in whom you'd found that genetic finding. and that's in their guidance on confidentiality from 2009. That was revised in 2017, where that specific example was built upon, and in 2017 the GMC said you must disclose in the public interest if a failure to do so leaves others at risk of death or serious harm. And that had always been GMC guidance for other areas of medicine, but not for genetics. And specifically in that guidance, they said you will need to balance your duty to make the care of your patient your first concern against your duty to help protect the other person from serious harm, whether or not they were your patient. Excuse me, that sounds worse than it is. And we so we built on that approach to sort of say it is actually when you're telling family members about genetic information, is that breaching confidentiality at all? So the fact that a particular person has a medical diagnosis, be that breast cancer or heart disease or a neurological condition, that is confidential to them. But the duty of confidence extends only to that information, not to the familial factors that have explained that condition or have predisposed to that condition. So the familial genetic predisposition is in itself not identifying of any one person at all. So arguably you could tell relatives of their risk in general without breaching the first patient's confidentiality at all. And so we argued that was a third way that didn't require breach of confidence. And we built on that in professional guidance for specifically for genetic and genomic practice. So me and several other people co-authored these guidelines, which I think helpfully have lots of anonymised cases from the Genetics Forum in them to illustrate particular issues. So the 2011 edition was the second edition, and then the third edition in 2019 tailored it much more around genomic medicine and mainstreaming of genomic medicine than the previous issue about genetic and clinical genetics. And we wanted to gather some empirical evidence also about this third way of disclosing familial information. And Sandy Deans, who was a research fellow in Sales at the time, did some really neat work looking at both healthcare professionals and patient views about consent and confidentiality. And she did a systematic review and a synthesis of the empirical research, and then did focus groups and individual interviews with health professionals and patients, and found some really striking differences between the perspectives of patients and health professionals. So mainly the health professionals said that they couldn't share genetic information with relatives because that would cause distress, worsen family dynamics. They did not think that you could separate clinical and genetic information like that. They were actually both the same thing. They were fearful of legal action, and they said that patients would not like it. And patients said that they assumed the healthcare professional would actually do that. They separated their clinical information from their family inheritance, and they imagined that this is something that the NHS would do automatically. So some nice quotes here. This isn't my information, it's about my family. I look like my mum. Is that my information? Can you say that's my confidential information? And can you put the result in an NHS database for my relatives to access without them finding out about me? So really for the first time demonstrated nicely that the expectations of these two groups were so different, it was a little bit worrying. And although the professional guidelines now clearly said that health professionals have a duty to consider the interests of others, there was still at that time no clear legal basis on which the health professionals could do so and set aside their common law duty of confidentiality. And the ABC versus St George's case is a very sad case about an inherited condition called Huntington's disease, which causes dementia and abnormal movements. And this case played out to much fanfare and much misinterpretation from about 2007 until the judgment in late 2020, just showing you how long it can take for a court case to work its way through the courts. In 2007, a 56-year-old man who had been described as a previously gentle and family-orientated lecturer became depressed and shot his wife in the head, killing her outright. And he was convicted of manslaughter on the grounds of diminished responsibility and retained in Broadmoor. In 2009, whilst in Broadmoor, he became unsteady on his feet and had unusual movements, and the neurologist made a clinical diagnosis of Huntington's disease and made a prognosis that he was likely to die of this in the next 10 years. The man's daughters each had a 50-50 chance of inheriting this condition from him, but he said that he did not want his daughters to be told. And the team involved in his care, the medical team involved in his care, worried that those daughters had a right to know, but felt that they could not tell them without the consent of this man with Huntington's disease. And then one daughter told the father's medical team that she was 8 weeks pregnant. The team discussed whether to tell her about her chances of developing Huntington's, but ultimately decided that they could not, but tell her by mistake some months after her baby is born. And she then has a test and finds that she has inherited the condition. And she then takes the case to court and claims that her father's clinicians were negligent for not advising her of her risk. And she says that she would have terminated her pregnancy had she known that she herself had inherited HD and therefore wouldn't be around to bring up her child. And the court case hinged around medical negligence, which I think is a bit of a distraction for us, because had the professionals been aware of the guidelines that already existed and the possibility of separating clinical and genetic information, they could have alerted the daughter of her risk, but they felt that they couldn't. In the court case, there was a lot of toing and froing. First of all, the case was struck out. There was an argument that there was no duty of care to the daughters. Then the Court of Appeal said, well, actually, it's at least arguable that there is a duty of care because of the proximity and foreseeable risks of the daughters inheriting this condition. And then in the High Court in 2020, the case was finally settled. Unfortunately, it wasn't settled in favour of the daughter, but it was settled in favour of a nudge of clinical practice, that it created a new legal and not just professional obligation to balance the rights and interests of at-risk individuals. So it said it brought in a duty to consider the risks to relatives and then act on that balancing exercise. And these are just two more papers that show you how much engagement there was in the legal and ethical spheres about this case, and how we can navigate that duty of confidentiality in a genetic setting. And just a couple more reflections about familial information. The dreaded GDPR, the General Data Protection Regulation. So often people now say to us, well, now the GDPR is here, you can't possibly argue that you have a duty to family members, or that this is not sensitive information that you have to keep confidential. And the GDPR says any information relating to an identified or identifiable person is personal data, and that genetic information is sensitive personal data. But think about this, that in this room we all share 99.9% of our genetic material. And so that 99.9% can't possibly be sensitive or personal. That's shared amongst all of us. And so it can only really apply to the 0.1% of our genetic code that is different between us, which equates to about 4 to 5 million variants, of which about 100,000 are rare. So I think for those you can argue the GDPR does apply. But within families, a greater proportion of the genetic code is shared. So between all of us here, it's 99.9%, but between the man and his daughter, it was 99.95%. So there, I think it's really difficult to argue that Huntington's result in him was confidential to him and not shareable with anyone else, because it wasn't uniquely identifying of him. And the second reflection is obviously in the pandemic about how does family and contact tracing compare? So telling the contacts of a person with an infectious disease that they are at increased risk without necessarily saying who the infected person is a bit like telling a relative that they're at increased risk of a condition without telling them in whom that was first discovered. And we don't seem to have struggled too much with that in the current pandemic. And indeed, there's a lot of experience of doing that in sexually transmitted diseases. So the contact or the family member may infer or think they know who transmitted the infection or the genetic condition, but that is not the same as breaching confidence. And I think the language around the pandemic has been much less about sensitive personal information. There is, of course, a difference between vertical, father to daughter, and horizontal, person to person and infection transmission. But can we bring ways in of treating familial disclosure much more like what we've been talking about in the pandemic? So my second theme is about the prevailing discourses around genetics and genomics and the implementation gaps that are created by them. So the prevailing discourse, I hope you'll all agree, is overwhelmingly positive and arguably poor at recognising context. I'm sure it goes without saying to people in this audience, but there's a very common assumption that all we need to do is get our genetic code, hold up a magnifying glass against it to know what diseases we are at risk of during our lifetime. And I'm not surprised by that, because I think all our focus, while this technology and genomics was developing, was on this sort of black box here of analysis, speed, cost, bioinformatics. And initially, when I first entered genetics testing for the BRCA1 gene, or the Angelina Jolie gene, wasn't even possible. But when it was possible, it took about 1 to 2 years to get a result, and that's just one gene. Whereas now, doing the entire genetic code is much, much quicker than that. So we've focused on the black box so much that I think we run the risk of missing some of the complexities around that box. And there's some of them there that I've already mentioned, familial aspects, but lots of others that I won't have time to go in detail that I think have been written about, certainly in the bioethical and social science literature, but haven't quite been implemented into or incorporated into practice yet. So we were very keen to see how we could try and bring a contextual approach to this translation. And we're lucky to get a Wellcome Trust Collaborative Award, so that's with Professor Bobby Farsidis and Brighton and Sussex Medical School. And we call that the Ethical Preparedness in Genomic Medicine, or the EpiGen grant, because it's all about trying to find ways to be more prepared to deal with the issues that arise in situ. So we've heard a lot about pandemic preparedness, but this is all about dealing with the ethical issues in a particular situation, particularly geared to new and developing technologies in healthcare. And implementation science literature has long highlighted the incredibly long delays between basic science discoveries and clinical translation. And I'm not going to go into that in any detail, but there's a wealth of literature about the gap in between, how the gap is not funded and how it takes much longer than people expect. But I think that the deterministic discourse in genetics imagines that that gap must be smaller, that you must be able to move from genetic code to clinical translation much more quickly. Kate Lyle, who's working on the EpiGen grant in the cells group, has explored this issue of socio-technical imaginaries, where she's really highlighted that how the future is imagined contributes to the making of the future. So if we imagine that the future is all technical and shiny, then we also we don't see the things that aren't technical and shining, and we have a domination of optimistic and deterministic discourses that mask the real life issues that need to be considered. And here are some headlines that illustrate that. There are many, many more that I could show you, but the reporting in the media is often of a very polarised debate. The real practical problems aren't covered so much, and genetic information in particular is sold as knowledge providing you with power, and a conflation with genomics transforming care for some, meaning or concluding that it will do so for everyone. And I think this enthusiasm is incredibly welcome, and we won't get the developments we want without it. But it's also really important to be realistic about where we should temper that enthusiasm and how we should address the gaps in implementation that may arise, and myself included. The implementation gap between my thesis predictions and now is quite considerable. And Rachel Horton, who's one of the new CPM JRFs, analysed some of the recent media discourse, looked at 105 UK national newspapers describing a personal story about genetics or genomics, and analysed images relating to genetics and genomics in a Google search. And the overall impression from that analysis, even though it was about personal stories, was that the results were shouting out from the genetic code, devoid of any clinical context, and that diagnoses and predictions are one and the same thing. Similarly, we found a public optimism when we did a YouGov survey of genome sequencing in healthcare, where these words in the word cloud are the ones that leapt out, and the more cautious ones about unclear or problematic were much less prominent. And one of the things that Kate Lyle and Susie Weller on the Epigen study have been doing is creating a cohort of longitudinal patient stories where they've interviewed people who took part in the 100,000 Genomes project repeatedly to hear their story through the genomics journey. And although I can't expect you to take all that on board, it's just to show you that the journey is much more complex than those deterministic discourses might suggest, and much less shiny, and that actually most people don't really understand the results that they've received. And the other thing not represented well in the discourse is that as technology has advanced, we have effectively moved from phishing to trawling. So when we first did genetic testing, we started with clinical signs and symptoms, and we fished in the genetic code for a gene that confirmed those. Whereas now what we're doing is we're trawling the whole genetic code to find out everything that's in the net, yet we don't quite know what to do with all the things that we find. Incidental, opportunistic, secondary findings, variants of uncertain significance are all terms that may or may not be familiar to you, but where we've really struggled to know what to do with them in big genomic ventures. And we've come to, we worry about what to do with them, about disclosure, before we've even decided whether this is a result or not. And again, Rachel Horton is trying to dig underneath this disclosure practice to ask how we come to construct a result in the first place. So if we start with signs and symptoms, then arguably we're looking for a needle in the haystack of our genetic code. But if we look at the whole haystack, we sometimes can't find the difference between a needle and a haystack. I'm not sure if that second analogy is a bit too much, but it's a nice picture. And just to give you an idea of scale here, I've already mentioned that between us we have about 4 to 5 million variants, but we each of us have about 50 de novo variants, which means that we've not inherited that from either of our parents, and that are rare, and that would in the past have been thought to be a confirmation, yet clearly we can't all have 50 different diseases, particularly not if we're healthy adults. And we're all, on average, a carrier for an autosomal recessive condition. That's where you're healthy, but if you have a baby with a person who carries the same condition, you have an increased chance of a child with that condition. So which of these many different variants are the results, and which should be communicated? And importantly, when should they be communicated? When we're talking about moves to sequence all newborns at birth, it's really important to think about whether some things that won't be relevant for decades, how they should be communicated and when. And also to think about finding, if we're trawling for fish in different waters, then we won't quite know how that fish will taste when we pick it up. So another way that we've looked at how a result changes is looking at expanded preconception carrier screening, or ECS, and this is part of a joint PhD program that we is just finishing with the University of Groningen in the Netherlands and Professor Irene van Longer's ethics, law, social implications group. And there we had one PhD student doing a study in a GP practice in the Netherlands and in a fertility setting in the UK, where both members of a couple were offered screening for about 100 different serious genetic conditions. And these conditions are all autosomal recessive inheritance, meaning that each parent must be a carrier of the same condition for their children to have a 1 in 4 chance of inheriting it. And what was interesting about the study is that we communicated the results to a couple, i.e. the couple only got to hear if they are both carriers of the same condition, not if one of them was a carrier of something and the other one was a carrier of something else, or only one of them was a carrier. Because we argued that was not going to affect their health and not going to affect their children's health. People said, well, what if you change your partner? Surely you need to know for that reason. Well, ECS is now so advanced, you can simply do a new test with a new partner. So is being a carrier even a result in this day and age? When previously, the way we found out about carriers was through the birth of an affected child. And my third theme is the relationship between clinical practice research and commercial activities. So I think there's increasing recognition that best care comes from close integration with research and industry partners, but that the mixing between those three sites needs to be much less clunky than it is now. So I think the view, certainly from governance systems, is that those three are immiscible liquids rather than baked together in a cake. And the 100,000 Genomes Project explored that with a public dialogue on genomic medicine, and here's a chapter that Mike Parker, Jonathan Montgomery and I published for the then CMO's, Chief Medical Officer's report on Generation Genome, where we argued that we needed much better engagement with the public about what they thought about use of their data in research and boundaries outside of the NHS. And again, we argued that the genomic social contract should be much more about reciprocity, altruism and solidarity as part of NHS practice. And it's indeed enshrined in the NHS constitution, but oft forgotten about. And Rachel and I wrote an article looking at the hybrid space where really it needs to coexist more comfortably together. And then again in the 100,000 Genomes Project, we looked at what people thought about consenting to taking part in this project that was both sold as a clinical diagnosis for them as well as a research venture in a rather sort of uncomfortable way, in that the 100,000 Genomes Project developed into the NHS Genomic Service, but also asked for research ethics approval of the research arm. And we did a survey of more than 2,000 participants on the South Coast, and we did in-depth interviews of quite a few, and basically showed that none of them remembered the main toggle that the research ethics approval had required of an informed consent process. And most of them didn't mind that because they trusted the NHS to deliver whatever it thought was relevant to them from their genetic code. This trust really meant that we needed to think about trustworthiness of the venture and transparency rather than have we got all the boxes ticked on our consent forms. And this is my last clinical example to show how partly how the context is really important, but also where when you stray outside clinical or research boundaries into commercial sector, how we can get very confusing results. So this is an anonymised Jane who received a direct-to-consumer ancestry test as a present, which are now sold regularly online and are quite affordable to many people. And because she'd read that this was possible, she asked for the ancestry test results to be sent to her as a raw data file. And she sent that off for secondary analysis to a different company who promised to also reveal some health-related information from that ancestry result. And that secondary analysis showed that she has a BRCA1 gene variant that is thought to cause a very high risk of breast and ovarian cancer. But she has no family history of breast and ovarian cancer, but thinks that she has saved the NHS a lot of money by doing this secondary analysis, and therefore wants referral for a risk-reducing mastectomy and her ovaries removed because of this increased risk. When her GP sent her to the genetic clinic to check all these things and to go on the pipeline for these operations, the sequencing on the NHS shows that she has no BRCA1 mutation. That's repeated. Nobody quite knows why that would be the case, but it turns out that this is not a rare event at all. And that is not news to any scientist involved in genetic testing. The particular technique used in this ancestry testing is called SNP-CHIP technique, which looks at single nucleotide polymorphisms or common variants throughout the code. Very commonly used in research and by ancestry companies. And the SNP-CHIP false discovery rate for rare variants is incredibly high. So it's really bad at calling rare things, and BRCA1 variants are per definition rare. And in fact, it's in a UK Biobank data analysis, it showed that 96% of the disease-causing BRCA variants identified via SNP-CHIP analysis are false positives. So in fact, Jane's chance of having a false positive BRCA1 result was 96% and only 4% chance of it being correct. So that's a worrying twist of direct-to-consumer testing. Hopefully it's not too frequent because not that many people send off their data for secondary analysis. And if you are, say, just doing a 23andMe test, you will only get the results that they promise to give you. So they're not going to they're not going to analyse your data and pull out the false positives. But the flip side of that is that 23andMe will only look for 3 variants in the BRCA1 and BRCA2 genes, whereas in fact there are thousands between different families, so that people might be falsely reassured that they have tested negative when actually they just haven't looked everywhere. And then the third reason to worry is that the predictor value of a disease-causing variant is often much reduced when found outside the context of the signs and symptoms and family history of the relevant disease, as I think I've already mentioned. And this has had some policy impact. We worked together with GPs, so the British Society of Genetic Medicine and the Royal College of General Practitioners worked together to make a statement so that when GPs are faced with the results of these direct-to-consumer tests, they know what to do. And we gave evidence at the Science and Technology Committee, which was very well received. And indeed, the report from that came out with a very useful recommendation, although it was recommendation 5 and rather sidetracked by a lot of regulatory recommendations. Recommendation 5 said the government should extend the scope of the performance requirements on direct-to-consumer genomic tests to explicitly cover clinical performance as well as analytical performance. Really important step. So not just go to a test and see whether it's analytically 99.9% accurate, because most genetic tests are analytically accurate. But what in that particular setting, what are the clinical implications, and how can we get people to realise that they need to focus on that when they purchase a test? And I wondered whether actually we should be thinking about some sort of rating system for genetic tests in different contexts. And we're all familiar with that particular rating system, but it doesn't have to be that, and it can be a different, wider scale. But just for an example, here is different BRCA1 results. So a good rating might be where you have a BRCA1 result where the familial cause of that BRCA1 of that family history is already known, a BRCA1 mutation has been identified, and a really poor rating would be for the example I've just described. And then somewhere in the middle would be someone who has whole genome sequencing at birth and a BRCA1 result is found. And I wondered whether we could develop that in different settings, so not just for a particular test, but different settings. Embryo screening for genetics is becoming increasingly popular. I've picked 2 there, but there's about 20 if you do a Google search of companies promising direct-to-consumer or kits to healthcare professionals to screen your embryos. And I particularly like, I don't know if you can see the LifeView one, that logo is choice, not chance. So implying that their genetic testing is 100% accurate because in its prediction, and of course no prediction is 100% accurate. But conclude by saying that really we need to now focus much less on the black box in the middle and the bits around it and the complexities, and that we can only really make progress along that line if that box is integrated with the rest. So this is my last slide. Genomic enthusiasm is really welcome, but we also need to focus on making the future of genomic medicine realistic. How genomic variation contributes to disease is complex and often much more so than expected. I hope I've argued that we need a much more situated and nuanced approach to things rather than look for a rule book approach or the common adopted risk-averse approach. And that bicycle there is very risk-averse, but you'll never cycle on it because you'll never find all the keys to that locks. I think we should embrace the complexity, empower patients, publics and professionals to participate in finding new ways of dealing with the issues that arise. And I hope that I've shown that by engaging with the molecular research, the clinical delivery, ethics and social sciences, the Centre for Personalised Medicine is in a fantastic position to play a really important role in reducing implementation gaps and allow meaningful interpretation of genomic data. Thank you very much.
That was fascinating. Thank you, Anneke, and welcome back.
Thank you.
And I'll start with, if I get a chance, a couple of questions or comments. So recently there was an explosion around an autism genetic study led by Simon Baron-Cohen, where the claim was that he hadn't done his public, that they hadn't done their public involvement properly.
Yeah.
And there was autism families that really struck out, and I think the study has been halted.
Yeah.
What are your views about that? What happened? And I've got in the back of my mind anti-vaxxers who dominate quite a lot of what happens in Oxford, because we're constantly under threat from those protesters.
I think there's 2 interesting issues about that. One is, I think you highlight by the mention of anti-vaxxers that the debate in this setting is often very polarised. We've got the genomic enthusiasts and we've got the naysayers, and actually we need to be much better at inhabiting that middle ground and getting people to talk to each other engage, not just the professionals engage with each other, but also with patients and publics. So I think that's a really important lesson from that. I also think that it's interesting that I think that folded because the population who it was relevant to hadn't been properly engaged with, and that's important to do so. But autism, of course, isn't that predictable by genetics, so that was sort of missed in that discussion.
Yeah. And something that comes up all the time is, my view to a solution to the planet is education. People say that we're not actually training our medical students properly in this area, and if we're not doing that, what hope do we have? How do we mend that?
Well, I think, again, that Genomics England and the NHS Genomics units have invested a lot in education. But actually, I'm a little bit sceptical about education being everything there, because there's a risk of that becoming a bit of a passive exchange. I just need to impart a load of information onto you, and then I can get my consent form signed. And certainly, that there's sometimes a tendency to go that way. And I think it's much more about engagement and embracing the complexities here. And I think I was reflecting when I was preparing this talk that the best patient feedback I've ever had is when I've said, I don't know. This is what I know, but I don't know this, and I don't think anyone else knows this. And that's when so when you're being honest about that, about the complexities, and you're not saying, here's this shiny new tool that's going to make all these predictions that are going to help you. That's what we need more of, rather than a sort of, this is a double helix, and the letters arranged around the double helix, and once you know that, we're going to do this sequencing. And that's being a bit flippant, because I don't think genomics education is all about that. But I think there is a risk of thinking that it can all be answered by education, when actually it needs to be much more about engagement and recognising the complexities.
Right. So I can rabbit on quite a lot here. Have I got comments and questions in the audience? Yep.
Sure.
Introduce yourself, please.
Sorry, Benjamin Schuster-Rugger. I'm a computational genomics lab leader in the Data Institute. But unrelated to that, really, I just saw a Twitter thread by you and Bernie a few weeks ago, where he was saying that some companies in the US now offer pre-implantation diagnostics for polygenic
risk scores. Yeah.
Risk scores.
Yeah.
And he was highly not in favour of that, but there was a big discussion about it. What do you view, and how does that relate to people's understanding of risk in genomic data?
So the embryo screening, that's pre-implantation genetic diagnosis, by another term, for polygenic risk screening, would be off the scale for my.
More about, like, clear Mendelian.
No, embryo screening for IQ by polygenic risk, that is not Mendelian. That is, that's offered, and that should be off any scale, I think. But I think that people often hear embryo screening or pre-implantation genetic diagnosis, that if it's offered, it must be a clear Mendelian disease, or there must be some evidence for it. So that's why I'm suggesting we need to really think about rating some of these tests, so that people can see quite easily, actually the test I'm having is way off the scale here, or the test I'm having is ranked quite high. Does that answer your question? I mean, I'd be completely with you and Bernie that
my question wasn't so much a question as a
comment,
some chipping in with some things to discuss. But
I think so. Polygenic risk scores are fantastic at predicting things for populations. I think transferring them to embryo screening, or to individuals, where really then you have a binary decision at the end of it. Do you implant this embryo or not? They have to be much better at predicting what they're measuring in order to base a binary decision like that upon them. This would be my view.
Do you feel that we should draw a line somewhere and say things that are worse than...
should be phased out. Yeah. I mean, I've based this, as you might recognise, on energy ratings, and the government has a policy of rating out, of filtering out F and G, so that you can no longer buy a light bulb that is F or G, or a fridge or something like that. So yes, I think we could do a very similar approach with certain types of genetic testing.
Helen?
Yes.
The person beside Helen.
Also Helen though.
Oh, you're Helen too. Okay.
A lucky guess, John.
So the Helen to Helen King's right. Please ask your question or comment.
I'd be interested in your thoughts, Anneke, about the differences, if there are any, between what researchers, in a quite a sense, think people want to know and what people actually want to know.
Yeah.
And whether this knowledge is wanted knowledge. In what sense?
Yeah, I think that's a really interesting question. I mean, I think I gave you the example of health professionals thinking they knew what their patients wanted and patients thinking they knew what their health professionals would do, and they were diametrically opposite ends of a spectrum. And I imagine that happens quite a lot. But, you know, thinking about the patients that come to clinic, there are a massively wide range of expectations. Some people come with an expectation of the shiny tool and are very disappointed when they can't have that, yet others are really happy to engage with that and realise quite quickly that it's complex, and the longitudinal patient journey I showed you, they were absolutely fascinated by having repeated interviews over time about their view of this journey and felt that was by far the most useful thing out of the whole venture rather than their genomic test. So I hope I'm not going too far in saying that, but you know, it's a totally different expectation than you might have thought. So I don't know if there's a generalisation that can be made there, apart from, I suspect that patients, publics often want something different than health professionals might think they do, and the only way of finding out is to engage more successfully, rely less on the technology and look at the patient in front of you, as you well know, Helen, and find out what's important for them. Does that answer your question?
I think so. I suppose it's also about the question of finding stuff out and then what you're going to do about it. Actually, if the thing you're going to do is not possible or acceptable, then
Yeah.
does it help to ask questions?
Yeah, I think that's really, so this knowledge as power is quite a powerful chant, isn't it? But if you're not going to do anything about it, and the Huntington's case that I showed you really struggled with that, because Huntington's is an untreatable condition. And in the court case, there was a lot of discussion about, if this had been breast cancer or if this had been heart disease, it would have been a totally different situation. But in her particular case, she was arguing that the only treatment available to her was to terminate her pregnancy. She argued that was a treatment for her, because she didn't want to bring a child into the world if she couldn't bring it up herself, because she was a single parent. So I think there's all sorts of nuances to that, aren't there?
Thank you. There's a question there at the back, and then I think Nikki, and then this chap in the middle. The chap at the back, do you still want to comment or question? Yeah. If you could take off your mask briefly, because we're trying to record this and understand. Oh, is that?
Yeah. Oh, yeah, it is.
It is.
The chap at the back. Yeah.
Great talk. Thank you very much. A quick comment, which is to say on the embryo screening by apologetic risk, and that's well beyond any line that might be what is ethical or reasonable. And then a slightly more technical comment/question on your example a couple of slides earlier on the three BRCA things, clear mutation by sequencing with family history, a mutation that's real and known to be damaging, but no family history and secondary ancestry data. There are kind of different things going on there. I'm sure you're aware. So the bottom one is an example where the data is potentially dodgy. The difference between the top line and the middle line is that the level of risk is different. But there's sort of scientific accuracy is there. As you say, we're currently not great at quantifying the risk in the middle category, but I think that will probably change quite soon because of things like ecovirus, like so many people, where we're ascertaining on the basis of the BRCA mutation rather than because of disease.
I think that's a fair comment.
Risk. And then even in the top line, we now know that a woman's risk depends not just on the BRCA mutation and family history, but on the polygenic risk score. So we're probably not being strictly accurate in saying your risk is this because there are other factors. So
Not just a polygenic risk score, but also environmental factors, whether she's overweight, etc., etc.
So there are sort of different things going on there. The bottom one is
Yeah.
dodgy data.
So don't get me wrong.
Two just differ in level of risk.
I wasn't thinking this was a solution. This is just an opener for thinking about, can we think of a way to rate tests? So you're absolutely right that if you look at the details, this is all a bit messy. But we've also got to simplify it. So for an individual person with a BRCA1 result, can that person look at this rating and say, where am I with this particular result? Where am I on that scale? Yeah, of course, I'm not saying this is thought out in any sort of detail, but it's a sort of concept. Can we use this concept in any useful way to give a context to a result that's otherwise seen as, well, I've got this BRCA1 result, it must be the same as this other person with a BRCA1 result. And actually it's not. It depends hugely on the context of how you find it. But you're right, there's other things that aren't in there.
It's not the tests that have a different rating there, it's the risk impact of the information.
Yeah, this is not about tests, so this is about your result. So is your BRCA1 result from secondary analysis any good? No. Is it from a predictive test in a family where you know the mutation? Much better. But yeah, you're right, there could be an A+ result as well. But we're never going to be able to predict these things with 100% certainty, are we? We can get better and better, but we're never going to be able to account for random chance.
Okay, Nikki, please.
Yeah, relatively simple question. I just wondered how often you think that informed consent is actually truly informed consent. And one of the reasons I ask this is I'm taking part in a kind of ONS COVID study and have been doing for maybe 2 years now. And I've got this consent form where we were kind of starting the blood testing, and one of the lines in the consent was basically, we can use this blood for any other research.
Yeah.
But it didn't even mention COVID-19 or anything.
Yeah.
And by the time I kind of said, oh, I'm not happy with that, my husband had already initialed it, because we were just given the form to take inside and didn't consider any of it. And that I thought was a particularly bad example. But generally where we're expecting people to understand the implications of genomic testing, I would just kind of how often do people do actually understand that?
I think I didn't have enough time to go into that in detail, but I think that's a really important point, that consent just can't do all the work here. We think we can make it do all the work by adding adjectives in front of it, informed consent or fully informed consent. But in something that has so many different possibilities and is so wide-ranging, it just can't. Really, all you can give there is permission and hope that the people that you give permission to will act in a trustworthy manner and be transparent about what they do and guard your data appropriately. But I think we need to get much more comfortable with thinking about the idea of broad consent. And I think I've always thought that informed consent is a bit of a, I don't know what is the word, tautologous? You're not giving consent if it's not informed, so why add informed to it? I think it means specific consent, and if it does, then you just can't give specific consent to these really open-ended ventures.
The chap in the middle.
Hi, yeah, great talk. I was just thinking, in the ABC case, how can you tell the daughters that they've got this risk of Huntington's without letting on that the father has Huntington's?
Yeah.
Or else it wouldn't have come to the doctor's attention.
Yeah, really good. I think that's a really important point. I think you can do it by saying to them, so when the daughter said to the health professionals, I'm 8 weeks pregnant, does that mean anything, anything I need to know? Then what the health professionals could have said is, well, you've seen your father shoot your mother, your father's detained in a psychiatric institution, you can see your father going downhill. That could be the result of an inherited condition. And if you want to go and find out more, ask for a referral to your local genetics unit. That's keeping it broad, it's not very specific, and of course you might worry about if she doesn't pick that up, but there are ways around it where she might eventually infer that she's inherited it from her father, but she's going to do that sooner or later anyway, and indeed she ended up doing that in a really awful way for her, where she was told by accident. And so, you were never going to prevent that from happening, but I think inferring where you've inherited from is not the same as the person who told you that breaching someone's confidence.
There are two events happening. One is called Our Future Health, 5 million, almost 10% of the UK population. And I think it's going to be much more flexible than UK Biobank, which is a revolution.
Yeah.
And then there are plans for GEL with Matt Brown taking over. And then the spending review said there's money for 100,000 babies, presumably from the general population.
Yeah.
So this is amazing. It's scary. It's exciting. But how, in God's name, are we gonna, or whoever, are we gonna handle all the issues that you've so well described tonight with those cohorts?
Yeah, I think it's really important that we do. How is by allowing them in. I think so far they haven't been allowed in, but we're slowly getting there. We're getting public consultations. We've got a head of ethics for GEL who's thinking about these things. Our Future Health has also got an ethics committee that's thinking about these things. So I think the will is there. But there's, as you say, there's a long, long way to go, and there's a lot of thinking to do about creating, at birth, creating a whole genome sequence of someone that is created to diagnose illnesses at birth. So it's newborn screening to pick up conditions early, but could be used to predict or diagnose all sorts of future things. And how we handle that bit after the newborn screening is the bit that concerns me, and that I think needs a lot of thinking about. But I'm sort of really pleased that places like CPM can influence that thinking by having these sorts of discussions.
Yeah, so listing the mistakes that we want to avoid going forward
with
exactly. Neonatal sequencing.
Yeah.
So how long will it be, do you think, before basically everyone will be sequenced, whole genome sequenced?
Yeah, technically I don't think it'll be that long. But I think, just sort of answering the previous question and that one together, I heard someone on the radio saying about the 9/11, the consequence of 9/11 was that people for a short time didn't want to fly. And so they took to the road because they thought that was safer than flying. And the increased road traffic actually resulted in more deaths than 9/11 did from the plane crashes or the towers themselves. So I think what we need to look at is what are the other consequences of these, people interpret risk in very different ways, and none of us are very good at knowing what to do with our risk. What other behaviours might we bring in that are actually more risky as a result of some of these predictions? So we need to look much more at that sort of undergrowth and clear some of the weeds away there.
Now, there's lots of potential for harm, isn't there?
Yeah.
I hope we can really keep up with informing people before
Yeah.
they do things like stopping things that were healthy, like a diet, or if you've got both parents with high blood pressure, I think you should be measuring your blood pressure.
It's cheap and easy to do. I suppose if the intervention was removing a limb, then you might think twice. So removing a breast is. So it's all dependent, isn't it, on how high the risk is and what the interventions are that you can offer. But measuring blood pressure is not a bad idea anyway. So yeah, absolutely agree.
And a healthy diet. Right. We've reached the limit here. So thank you, audience. Thank you, Anneke.
Thank you very much.
Thrilled to bits to have you back and with hanging your hat in the Welcome Centre. And thank you very much to CPM, the funding agencies, the donors, which are absolutely key to this. Thanks indeed.
Thank you very much.